So I guess today we'll continue the random variable. Hopefully we'll finish the discrete version, and then on Wednesday we again have the lab section. We'll do the continuous division together with the RNXL. It's not the RNXL is not something for this one because we just simplify the calculation by plugging in some formulas. So you learn the function idea, so probably this is something very similar. So can you hear me? Yeah. So let's repeat what is the random variable. What's a random variable first? So the idea of random variable again is to simplify the sample space, because sample space is rather a complicated concept, right? Because look at the world, you have uncertainty, then you have the description of the world, right? Say, for example, look at the stock market. You look at every single stock, then it will be difficult, right? So that's why when you look at the thing, the stock market, we look at the stock market index, right? We look at the economy, look at GDP, right? Instead of looking at the whole economy, how everything works, right? And that's the idea, right? Same as when we look for a job, then basically look at the people, look at the HR, look at your GPA and so on and so forth, right? So that's the idea, right? Just summarizing or simplifying the outcome of the random experiment or outcome of the randomness by a number, right? That is what we are going to do is a one-dimensional number, right? And that makes things easier. And what kind of number you can make, right? If number are only discrete type, means that you can count them. Then it's called discrete. If this is uncountable, in the sense that if you suppose you have two numbers, anything in the middle can be fine too, then it's a continuous. Okay, so this is the reason why they distinguish these two is not because of they're somewhat different, but it's somewhat different in the math treatment. So the math tools we're using a little bit different. Okay, so to describe discrete and continuous, we rely on two different tools, right? Either is the probability function data you will see, and the distribution function, sometimes called PDF or CDF. And for the discrete version, you can do add and subtract. That's no problem. But for continuous, we have to rely on differentiation and integration. Okay, and those because our class doesn't rely on integration or differentiation, but what it actually means, just in terms of basic idea, is just differentiation is about finding a slope, right? Integration just finding an area, and basically we're talking about the area. Okay, just area you learn from your elementary school, right, or primary school. So don't worry, it will be something you will know more when we go. Okay, so just to remind you that this example, if you toss a coin, right, you have head and tail, but you just, instead of head and tail, you just count number of head or number of tail, right? Same as if you toss the coin twice, right? Instead of 4 outcomes, which is head and tail, you just have number of heads and number of tail, right? If you toss the coin 10 times, right, then you can just see how many outcomes you can have is 2 to the power 10, which is 1024 numbers of outcome. But when you really talk about the number of heads, the number of outcome is just from 0 up to 10. Okay, so we just say 11, right, instead of 1,000. So it's just like much simplified, much more manageable. Okay, the one of the drawback is when we simplify the number of outcome, one of the drawback is not every outcome is likely, even if you have a fair coin or fair toasting. Okay, then you will have saying each realization, say in this case 0, 1, 2 are not equally likely, right? 0 and 2 are equally likely, but 1 is more likely than 0 and 2, right? So in that case, you are actually, for each value of the random variable, you have different probability. Okay, so that is something that to study how the number is mapped to the probability, right? You give me the number of the random variable, what is the value of the probability will be the basic thing to describe a discrete random variable. Okay, that is called the probability function. Okay, but we will talk about this very soon. Okay. Next is again the example is the, as I said, the stock market, right? Stock market index and also temperature. They are very naturally continuous random variable, right? So go to discrete random variable. So just to remind you that the this is called the PDF, or sometimes it's called PMF. Sometimes you can see the book, they call probability mass function. Okay. Instead of this function, they call mass MASS, PMF. And this is called cumulative probability function, but sometimes they call cumulative distribution function, CDF. So I don't know which I should follow the term. I think I'm following the textbook. Actually, I don't like this name, but that's for your easier to match the book. But maybe I should change it to the more general fitting what is in the public textbook. But anyway, so that is the idea. But this is very simple. Just what I said is you give me the value of random variable. I give this function, we give you what's probability. Okay. And this is just adding up, right? Because the summation is summing, adding, right? Because it's equal, less than or equal to, just adding, right? Adding any number that is equal and below. So do note that there's an equal sign. Okay. Why this is convention of the function is going to be left continuous, but anyway, this is how people divide. I mean, define in this way. I mean, so he can see the example 1 to 6. Okay, each equal likely, then you add them. Each one the probability 1 6, right? F of x will just add up, right? Because this is just this, and just make sure you understand. Just try to be very briefly, right? This is this guy, just sum of these two guys, right? And this guy's with just this guy. Okay? So don't worry, you will be working homework on that later once we finish this, right? Just remember you have homework too. I think the deadline will be this this Sunday, midnight. So it should not be difficult, but I should not talk about homework 3 right now, but homework 3 will be doing something like this similar, right? But I shouldn't talking about. But already I see some of people already submit the homework 2 already. But should not be difficult. So just go to here. I think we stop somewhere here. Okay. And expectation and variance. Okay. So just to remind you that the intuition behind we do this. Okay. This is no different from what we learned in topic 1 about mean and variance. Okay. Topic 1 mean and variance is you have a data, you calculate mean and variance. Remember what is mean and variance? Mean and variance is for mean, right? Just adding up all the observation, divide the total number of them, right? Just to remind you, maybe I'll write that down here, right? The mean will be just summation, adding up all the observation over n, right? But this would be the same if you consider this a weighted average is okay. If this is equal to the frequency. Okay. So what I meant here, just make an example, then you understand. Okay. So what is this? Suppose xi is like this, right? Here, right? Suppose xi is 1, 2, 2, 3, right? But this is data, right? But you can write it in the what we call the distribution function table, right? 1, 2, 3, right? How many frequency of this? This is 1, this is 2, this is 1, right? The mean of x can be written as 1 times 1 plus 2 times 2 plus 3 times 1 divided by 1 plus 2 plus 1, right? So this is our standard meaning of mean, can be saying as consider the weighted average, where the weighting is the frequency, right? But also you can write it as the other way is 1 over, if the way is over 1, total sum of them is 1 over 4, 2 over 4, 1 over 4, right? So you can divide it into. Why I do in this way? This is 1 and this is probability. Okay, so exactly what is here, right? This is the value weighted by, this is the frequency actually appear when you do the data, right? But this is just the P, just hypothetically in your mind, you think that you run this experiment again, and again, this P will be the relative frequency, right? That's the meaning of classical probability. Okay, so this is exactly the same thing. Similarly, the variance is exactly the same thing as our variance, just a different from the mean and do it. Okay, so that's why we learn topic 1 before we go for this, because they're exactly the same thing. Okay, the difference is the topic 1 is you have the data, we repeat look at the data and calculate mean and variance. Here is hypothetically in our mind, we do our experiment many times. Okay, and probability actually means the relative frequency, so that's why this is the case. Okay, so this definition now, and just the die, right? Die have number 1 up to 6, each one equally likely. So it's 1 times 1, 6, 2 times 1, 6, 3 times 1, 6, 1, so forth. Okay, and you calculate 3.5, and variance will be each value minus the mean, x squared times probability, and so forth for each one. Okay, so don't worry, you'll be working on something similar for assignment. Then you should be able to know how to handle this. Okay, so you will be working on that. Okay, so of course I said to the top of assignment 3 is assignment 2, but this is a math class somewhat. I mean, you can do business, but you have to do some practice. Okay, in order to know more. I mean, do remember my lecture notes have a lot of questions which have answer. You should try to check out those, or you could check out the textbook. If you have bought one, then they have also have, I think, even number of questions have solution at the back. Or you can go to library and pick up any books in statistics where they have answers. You can work on those, because this is so basic, then everything is fine. Okay, what I taught is not something very special topic. It is so generic, so you can pick up any book and can work it out. Okay, so just to talk about some property of expectation. Okay, so I don't think we covered this, right? We haven't. So just slowly to go through, but before we start, any question? Any question before I go? If no, then I will just give the idea. What are they? Okay, we're not going to prove it. Okay, the proof is rather simple because it's summation adding. Okay, but to give the idea, what's this? I give the example from the perspective of, say, finance. Okay, investing. Okay, so what is here is consider that A and B are constants. Constant means that they are unchanged. You can A maybe 1,000, or 5 or 100. So it's a number that is unchanged. There's no uncertainty over there. Okay. And X and Y here are random variable. Okay. Random variable, you can imagine maybe the stock price. Okay. Or the stock return. Okay. So here you can see the first equation. It's called linear probability. It means that expected A of X is A times expected value of X. What does that mean here? Okay, it means that suppose X is the stock price or stock return. Okay, suppose you invest 5,000 stock. Okay, or 1 million stock. Okay, do we need to calculate this expected value? How can we do it? You can just don't worry. You just need to calculate the expected return or the expected stock price for one stock, then multiply by the number of stock you invest in. Okay, so that's why you look at the finance, look at people talk about the rate of return, right? Just talk about rate, okay, or percentage return, right? You don't talk about the whole return project of the return. Okay, so that is the reason why this kind of thing would work. Okay, do note that this would work, right? Would be meaningful. Okay, only meaningful because the assumption that you are, say, in the finance, you are small in the market. Okay, if you imagine that if you're big in the market, you buy more stock, the stock price move. Okay, you move, actually in most cases move up, right? Actually your return will be lower. Okay, so that's why when you look at, you can see the look at the return for a much smaller fund, they can do very well. Okay, but when they do well, people come in and buy, they become big, then their return actually get lower. Okay, so this linear thing, when we talk about this, will only make sense that actually this thing, this is actually independent of dx, right? How many actually the return, right? You can write this because of you're small, that thing it makes sense, right? But otherwise, if you can imagine that if you're working for a big fund, okay, or big investment bank, this thing doesn't really hold. Okay, but for most cases, when you are a small investor, this would hold. Okay, so that's have to be something careful, right? The math that is correct, right? But if you write this, there's an underlying idea when we talk about constant, right? Means no matter what x, a is the independent of x. Okay, but in the real world, it's not exactly this case. Okay, if especially you and your big fund or you're investing for the big company, right? Then what you're doing can be changing. Okay, so you have to be very careful all about this. Okay, so it's not very simple problem, right? I think probably someone, but you may know the maybe you guys are too young, but there's a maybe 20 to 30 years ago, there's a very famous bank called B.B.A in the UK. I think the guy is a very smart guy, and he trade the futures, and he always win. And sometimes that he wins so much that the company give him a lot of budget to trade. And at one point of time, he trade actually not a lot, but people know he's trading, and just the other investment bank tried to bet him off, right? So suppose I think he tried to bet that the Japanese index Nikkei is going up, maybe going down, and all other players try to buy up the stock, and then that's basically the company go bankrupt. I think it's one of the oldest bank in the UK. Yeah, I think even the Queen of England put money in that bank. So I think it's old days. I think you guys are too young to know that story, but happen, right? When your company or you get noticed, then I mean this need not be linear. But anyway, this next one is not, it's okay, it's not that problematic. The next one is stock, say the stock invest plus some constant will be, you can take the constant out. Okay, what does that mean is actually what we do, right? When we invest in the stock and the bond, okay, and or stock and saving, okay, whatever. you can separate the two, right? Because most likely the stock and the bond will be independent, right? Especially this bond is government bond, is relatively, especially US bond, right? US can just print the money, okay? So it's never default for that purpose, right? So that's why you can distinguish that, okay? So that's why when you talk about the stock market, usually you can save yourself from talking about how much saving you have, right? Of course, again, this is only true because of the saving is safe, right? In the financial crisis, saving is not safe. So this, even the bond from the government is not safe, right? Just go back to the original story, an original related story, but probably this is the time when you were born, I guess, right? You're 18 now. No, you're still too young. So it's 1997, right? It's the Indonesia financial crisis, right? And also 1998, there's a Russian crisis. That was 1997, yeah, 1997. So there's at that time there's a very famous Hong Kong financial firm and go bankrupt. Why? Because they invest on the Indonesian sovereignty bond, and they pay high interest rates, very high, maybe I think 6 to 8%. And then they think government bond, right? Not going to die, right? Just borrow money from Hong Kong and just buy the bond in the Indonesia. And suddenly Indonesia, the currency fluctuate crazily. Then just, I mean, even you think it's constant, then not really. Okay. So let's go to the next two. This is somewhat same as this one, right? Just this one, take it out and apply this again. You just do this one, okay? And the last one is something very interesting formula, is to invest in two stocks, X and Y, okay? And you invest A amount of X and B amount of Y. So what's the expected return for your portfolio, okay? Will be just A of X and B of expected Y, okay? It's rather interesting. It doesn't rely on whether X and Y are related or not completely, okay? The random variable, we don't care talk about his covariance. We don't define covariance here, but you know what's covariance. Just same as there are two random variable, you just have this and you calculate, right? And we talk about covariance soon, but you will see here when we talk about expected return, okay, is independent of how the assets are related, okay? So this is not true for variance, the risk, okay? For the expected return, it doesn't matter how they're related, okay? But for the variance, you care, okay? For the risk, you will be involved there, okay? For the return, the expected return, you don't really have to worry about that part. You can separate the two and calculate sum, okay? So if you are trying to find what is the portfolio that maximize your return with regard to the risk, just do this, right? Just figure out what is the highest return, okay? And then if good, because linear, right? Just what you're going to do if you don't care about the risk. Suppose A and B is the amount you invest. So very simple problem. So what you're going to do, you don't have a risk, you put all your egg in the same basket, right? You put as many money as in one of the thing, right? Because you don't have a risk, right? You talk about expect the value unless you are moving the market. You're small. What are you going to do? Just put all the money in the investment that gives you highest return. Okay. So what are you going to do? Go to Macau casino, put all the money there, one shot and go. Right? That's to maximize your return. You don't have a risk. Right? That is the best thing to do. Right? But of course, we know we care about the risk. Okay. So putting all the eggs in the same basket is wrong. And we'll talk about why if you put your money in different basket, your risk will lower. Okay, very soon talk about that. There is a little variance, of course, but this is the idea behind the investing. Okay, but of course, this go beyond investing, right? Because this investing just an example that to try to tell you what are the uses of this formula. The proof will be this, okay? As I said, I don't want to gain the proof, but I think the proof here will be easy to read, okay? If you are seriously want to know, I recommend you watch the video I post on the YouTube that you can go. But I think this every single step I never skip. So I think should not be a matter. Okay, you may ask the TA, or during the break you can ask me if you're really interested in this. But I guess most of the case you don't. And I think previous cohort, I talk about this in detail. I think they're not very happy. Okay, so that's why I learned from mistake. Okay, I learned from my error. So I just don't want to talk about this unless you want me to talk about it. Okay, otherwise I just skip it. You may ask, what do we learn extra by skipping the proof? Is we cover more programming. Last year I didn't cover R. Okay, so this year I covered R in detail. So hopefully there will be more useful, more efficient use of time in the classroom. Of course, you can tell me now or later if you think R will be good. Okay, if you think it's not good, then maybe next year I can talk about Python. Or I can remove Excel and replace it with Python. There's no same for me. But anyway, go to the variance. Okay. The question would be, okay, calculate the expected return, like still in the mind of investing. Just make that easier. So variance is risk, right? Because it's how varied the return is, right? The risk. And we give you two formulas, okay? Actually, three formulas here. So the first formula is nothing but to make your calculation easier. Okay? So let me give you an example why this would be an easier thing to calculate. Okay? Just give you so just to I make the example of tossing a coin 2 times. Okay, just tell you how you calculate and see how this equation make easier. Okay. So this is the first equation is just for the calculation purpose. Okay, there's nothing other than if you do it by hand, it's easier. Okay, and also we need it because of this will make our proof easier, but we don't do any proof. But that is the reason we put it here, because when you read it by yourself, you want to read it. If you want to, then it will be reason why this is true. Okay, but let's go to tossing a coin 2 times, right? We have we have 0, 1, and 2, and probability will be 1/4, 1/2, and 1/4. It's tossing a coin 2 times, and X will be number of head or tail, depends on what you like, right? This correspond to, suppose this is tail, this is head, this is tail, this is head, tail, and tail, head. So that's why you have this. Is that okay? Is that okay? Just we have this already, but I try to show you that why this is easier. Okay, it's easy to calculate the expected return. Sorry, expected X will be just 0 times 1/4, 1 times 1/2 plus 2 times 1/4, which is 1. Is that okay? This is 1/2, this is 1/2, this is 1, right? This is 0. Is that okay? It's not fast, right? Let me repeat. This multiply this plus this multiply this plus this multiply this is here. And this 0 times 1/4 is 0. This is 1/2, this is 1/2, this is 1. Is that okay? And okay, how to calculate variance of X, right? So probably if you do it directly, right, you will be doing is 0 minus 1 square, right, times 1/4, 1 minus 1 square times 1/2, and 2 minus 1 square times 1. Right, this is the definition. Right, there will be 1, this is 1/4, right? This is 0. This is also 1/4, right? 1/4 plus 1/4 is 1/2. Is that okay for this one? There's nothing new here, but just to actually show you how to calculate, right? And so how is it related to this equation? Okay. Now, this is 0, 1, and 2, right? So if I consider x squared, what are the possible value? Is 0, 1, and 4, right? Because number of head square is 0, 1, and 4. Okay, so the probability is the same. Okay, the question is, what is this guy? The same idea here is 0 times 1/4, 1 times 1/2, 4 times 1/4. Okay, 0, 1/2, 1, 3/2. Okay, so let's look at that equation. Expected x squared minus expected x squared, which is 3/2 minus 1 square. You may think this is still easy, okay? But when this thing a lot, you do a lot of subtraction, the life is very difficult, okay? As I will tell you that this equation is much easier, much more manageable when the number of x expand, okay? But this is just to tell you that if you learn computer science, you will see this is the operation. This is easy. Number of steps is this one, this one is much smaller than this one. Okay, but this shortcut formula. Okay, there's nothing new to be learned from here except much easier to calculate. Okay, and the next one is rather important. Okay, the variance of your portfolio. Suppose you invest A shares of X plus some cash in your bank. Okay, so the variance is actually independent of how much money you put in the bank in B. Okay, so that is the reason why look at any whatever portfolio, right? You just talk about the return, the risk of investing in particular security, right? The assets. Okay, you don't really care about how much you invest. Okay, and one thing is very important here. Have to be very careful. If you invest A amount, your variance will be A squared times the variance. Okay, because the reason is square. Okay, so that is a complicated thing. Is you invest 1,000 stock. Okay, the variance will be 1,000 square times of that. Okay, so but do note that when we talk about the risk, is talking about depend on whether you care about the variance or standard deviation. If the standard deviation is the thing in your mind, doesn't matter, right? Because you take a square root. You take a square root, the risk is still linear. Okay, have to be a little bit more careful. But if your risk measure to you is a variance, which usually how people model it. Okay, if you look at most of the model, people use the risk measure as the variance, not standard deviation. Okay, because people actually maximize the mean and they call the mean variance minimizer. Okay, so in that case, this will be crucial. It's not linear. Okay, the usual measure is the variance, not the, in finance, at least as far as I understand, people do is the variance measure. Okay, so why I so emphasize about this is because the square, right? Which means that when you invest slightly more on this, the risk exposure is concave, right? Its exposure increase much more. Okay, so it actually gives the idea that you would be not if you're risk averse, as most people are, you will not expose yourself to much risk, right? Because depending on your risk acceptance, tolerance, you invest in 1,000, actually your risk actually is square of that. Okay, so that's why you will diversify. But we'll talk about diversification now. Okay, but at least we'll tell you that you will not. This is square. Okay. The second thing I want to talk about is this one. This is special case. We'll talk about general case in the next slide. Okay. In this particular case, okay, if the two stocks are independent, okay, then variance of you invest some of this with some of their own. Okay, so that means if you talk about the case where the two market are independent, okay, you can talk about the risk separately. Okay, why? Actually, we are doing that all the time. Okay, there are many risks in our world. Okay, we would not talk about the risk of investing together with the daily risk, right? You don't talk into consideration how much you invest in the stock market into thinking about whether I should play the bungee jump or I should eat the raw seafood, right? They're taking the raw seafood as the risk, right? You talk about this because they're largely independent, so you can take them separately. Okay, and that's why when you talk about risk in stock market, right? You talk about the risk of investing in, say, US market or risk in the India market, right? Because most likely they are, of course, globalization makes everything related, but they are not so correlated, right? And talk about, say, X may be the stock market, right? And Y may be the coin, cryptocurrency, right? They're less likely maybe independent. Okay. In that case, you can just sum of them. Okay. And we will show you this is only true when it's independent, right? And when it's independent, in most cases, they're unrelated, they're independent. Okay. And let's go to the case where they're not independent, which is the general case. Okay. But before we talk about that, we need to talk about the idea of covariance. Okay. If they're not independent, they're covariant. The covariance, okay, to define covariance, this is something more technical, is we need to define the joint probability, joint distribution. Okay. So we don't go into further detail, okay? But you can imagine that the outcome of random experiment, instead of talking about mapping it to 0, 1, and 2, okay? You map to two numbers. Okay, it's more advanced. It's not making one number, you're mapping to two numbers. Okay? And you can imagine why you make two numbers. In the world, we imagine that I invest in X will be the return of the stock. Y may be return on bond. Okay, they're two separate things. Okay, you want to have two separate things to capture these two. Okay, instead of talking about one variable, which is maybe your portfolio. Okay, and we're not going to detail, but this is just the probability, right? And have the same idea, you can calculate the covariance, right? Look at different number X and Y and how they appear together, right? This is the relative. You imagine two-way table, right? This is the relative density. Okay, and to calculate covariance. Okay, if I black, that means that it's not. I don't want to talk about the detail because they are technical. Okay, but what I want to say is this equation. If they're not independent, okay, the variance of your portfolio where you invest X and Y, okay, will be sum of them. Okay, so this is the first two part is you know it already. Okay, if they're independent, this is the variance. Now the key is this guy, 2 times the covariance. Okay, so this is the key of investing, right? So because you know, if you just care about expected return, that's what you do, right? Just go to Macau and then you're done. Okay, you don't. If people ask you how to do investing, are you care about risk? You say no. Okay, go to Macau and just once bet all the money there and then you go home. Okay, very simple. But now we care about risk. Okay, you cannot just put all the egg in the same basket. Okay, you have to put different things, right? You have to maximize your return at the same time. You don't expose yourself to much risk. So how do you do about that? Okay, you need to care about how your different investments are related. Okay, this is covariance. Okay, covariance, remember, is what is asking whether they move up together, move down together. Okay, you can see in this equation, if covariance positive, the variance is larger. That means that if you invest in two things, okay, they always go up and always go down. Actually, the risk is larger. Okay, that means that if you want to reduce your risk exposure, you want to invest something that they're not moving the same, right? For example, if you look at the people, why they look at they want to look at the emerging market. Okay, US people want to look at the India market, the Brazil market, right, or the Chinese stock market. It's because they think that that is unrelated or negatively related to the US stock market, right? So in that case, negative, that reduces the risk, right? Why people care about, so many people want to invest in cryptocurrency, right? Cryptocurrency is unlikely to be related to the real world, right? Because something is just some number, just some ledger, right? There's some record there, okay? It's not related. So that's why these are unrelated, right? And that's why so many people are collecting stamps, collecting wines, collecting cars, collecting sports shoes, collecting watches, right? They're really unlikely related to the stock market, right? So in that case, this is good, right? And that's why I talk about diversification, right? Just to try to invest things that they are negative related, right? And also this idea about hedging, right? So if you buy a lot of stock, right, you worry about your position, then you short some of it by futures or by options, right? So that is the idea, right? So that is also, I think there's some common thing you see in the real world, right? There's a lot of just I finish this story and then we have a break. Okay, there's you see a lot of I think movie and TV, right? And a guy suspect his wife or girlfriend is having an affair, right? To hedge his risk, he tried to met some of the outside girl first, right? In case if something goes wrong, then he has some hedge. Okay, the same idea here. Or sometime when you see the economy is not doing well, and you look at you are not. I mean, this is the same case, right? I mean, but some people from the Cathay Pacific, right? People know Cathay Pacific, the airline, Hong Kong airline, and I think this past few years is not. Last year, especially COVID, people are staying at home, and some of the people actually starting their own minor business, right? And this is the same idea, right? Because you try to do something is less related to what is happening in your airport business of the or your employer. They try to hedge, right, against that. Okay, so so we will be coming back after the break. Let's talk about this more detailed example of what kind of application on this will be all this. Okay, but let's have a break first. It's a break until it's a 10 minutes break. Hi. Hi. Can you hear me? Hi. Can you hear me? Okay, good. So, I guess before we go to a more detail on the discrete random variable, I want to give you the example that how you calculate the risk and return of your portfolio. Okay. In this case, I so make my life easier. I consider you invest two stocks X and Y. Okay, and they're independent. Okay, and if they're not independent, you need to know their covariance to calculate the risk of portfolio. Okay, but the idea is the same. Okay, just the same, very similar formula, but adding the covariance term. But just give the illustration. Okay, the stock of X have returned. This is a rate of return. Okay, 0.1 and 0.05 as a mean and variance, and same for stock Y, the independent. And now consider the case where equally divided into X and Y. Okay, so it's half of X and half of Y portfolio. Okay, of course it can be not half and half. Okay, then I show you how to calculate half and half. This gives you the return and the risk, right? Mean and variance. Then you can try to change the composition. Okay, and you achieve different mean and return, right? In this case, you can see X have higher return but also higher risk, right? Then you can decide what it will be the optimal mix based on your risk tolerance level, right? In here, suppose I calculate the return of this half and half strategy will be half of the return X and half of return Y. Okay, so will be 7.5%, right? X is 10%, Y is 5%, right? You mix half of them is 7.5%. Okay, so that comes from actually linear property of expectation, right? It's linear, right? Because 5%, 10%, half of each will be 7.5. Fair. Next one, variance. Okay, so if you invest one, will be 0.05, okay, and if you invest Y, will be 0.01. Okay, so if you mix, right, will be somewhere mix 2, supposed to be, right? If you invest everything in X, the variance with the portfolio will be just this one, right? If you, everything in Y will be this one. So if you invest mix, okay, will be somewhere in between. Okay, and you can see in this case, okay, the variance they use the formula is slightly bigger than this one. Okay, so this is in fact pretty good, right? Because if you want to do Y only, right, maybe you just, if you don't really risk averse, actually you want to combine the two, right? Combine the two, just raise the variance by a little bit. Okay? But your return is much higher. Okay, so that is and of course this is the finance class. If you go to finance class, they will tell you how to find the mix given how risk level you can accept. Okay, that will become optimal portfolio. That will be, if you know the CFP, yeah, CFP. Then they will talk about those. Or CFA also talk about those too. But it's not my job to teach you how to invest. Okay, it's not it is not a finance class. Okay, I used to teach those things, but now I'm not. So just talk about this probability. Okay, this application. Is that okay? So if you will, probably you learn more when talk about the finance class or investing class, maybe 3,000 investing class to talk about how to all combine this here and there. But it's not my job to talk about those. Okay, but just to give you an idea, why this thing will make sense. Why we want to talk about mean, about variance, but investing is That's the way, right? Although talk about investment, but this is the same idea when we talk about a firm try to whether he want to sell product X or product Y, right? The combination, how to sell to the market. Product X will give you this, product Y give you this, so on and so forth, right? So same idea, okay? So it's not something just for investment, but other thing as well, okay? So as promised, we'll talk about this 5 common thing you can make the model, okay? So the idea behind is the following, okay? Now we don't talk about the samples, I mean the complicated sample space and the outcome, right? We talk about the random variable directly, okay? And the good thing is, actually in the world, when we consider many random variables in the real world, actually fit into several common categories, okay? And the most common one, actually, you know, is bell curve, which we'll learn next class. But for the discrete version, actually, there's for our purpose, actually there'll be 5 of them, and 5 of them will have a lot of business application, okay? Why I focus on them is because this is often arise in the business application. So we study them in detail, okay? There's nothing new in this thing there, but it just, when the application fit this kind of cases, we have already calculated things for you to make your life easier, okay? We're still doing the mean and variance, right? But we don't need to calculate from scratch, because for these cases, mean and variance has special formula to make our life easier. So that's why we learn those, okay? Everything you learn from the mean and variance are done, okay? There's nothing new from this 5. We copy this 5 because this 5 has special formula and the special property and the special application. That's why we want to go a little bit further, okay? And because we don't do any proof, so we will just I'll focus on application, okay? Do remember when I talk about this, you have to think about the application in your mind, okay? It's not about the proof. Although I will do one single proof to highlight how do you do the proof, but otherwise you will not be anything about with the proof. The first one, uniform, okay? Uniform is something very simple. It's just saying that, okay, remember we know what are the value of X, okay? It can be anything there, but we just don't know the P, okay? Then what are the common P you can make assumption to the calculation? The first one we make assumption is every outcome is equally likely, okay? The real classical thing, okay? And why you'll be doing that? You'll be doing that if you don't know anything, okay? So suppose I know what the outcomes, okay? But I don't know which one is more likely, which is very often, right? Unless we have some experiment to know. Then what we're going to do is to make each outcome is equally likely, okay? And of course, the question is, we make this assumption is crazy because most of the time it's not equally likely, right? But then how you can make yourself better is what we learned in last class is called the Bayes rule, okay? That's how the real world works is when you don't know, you know all the outcome, you just make them equally likely. Then you have learning process, either machine or human learning. You learn which outcome more equally likely, then you revise this according to the Bayes rule or other procedure, then you come up with the real one, okay? But most of the time, if you don't know, just put everything equally likely, okay? Well, then the same when I talk about the standard case, talk about the random walk, right? We talk about the financial market, talk about we don't know tomorrow the stock price of today is going up or down, okay? If you don't have any good idea, then what we're going to do is assume up and down equally likely, right? Half and half, right? So this is something actually we do all the time, okay? Equally likely. And it means 1/n, right? The standard case is fair con, fair die, but also the cases you don't know what happened. Okay? That is equally likely. Okay, so there's nothing new here, but just this is standard way to do it. Is uniform distribution, and if you draw this P of X, right, it's rather simple. It's just like a flat, equally tall for each value you assume. Okay, if you have 1 to 5, it's like this. 1 to 3, like this. Okay, the more you have, then the more lower, but equally likely. Okay, so there's nothing special for this one. Well, I mentioned this because it is so commonly used. When we don't know anything, this is the way to go. Okay, we know what are possible value. Okay, we just make it equal. Unless we have some more knowledge, then we just assume they're equal. And this is actually how most of the time we do things. We don't know, then just equal likely. Okay. Now we come to a more interesting application. Okay, this is what we call a polynomial distribution. Okay, so what it's doing is, in this case, it's actually the simplification of sample space partitioned into 2 parts. We call success and failure. Okay, so we don't care how success they are or how fail they are, how bad they are. Okay, for example, is in the exam, right? I care about whether you pass or fail. Right? I don't care how good you're above the passing mark or how below you are there. Just when above is positive and below negative, right? Just what you do it all the time, right? We care about how the medicine, right? You know, probably now we have new COVID medicine, right? You just only care about how good it is, right? You just care about whether the medicine is useful or not useful, right? You don't really care about how efficient it is, right? Maybe you take 1 more day to recover. Maybe you have to take medicine for 5 days, 6 days, 7 days, 8 days, 9 days. As long as they recover, it's called success, right? Or take the medicine, they don't die, and then successful, right? Don't care how painful the process is or how other things go on. Just care about the success or not. Okay, and this is the basic thing, right? Whether you have things, whether one asking you success or not success. Okay, and the good thing about doing this, the simple thing is, you need not say that equally likely. You can have P successful, which is can be different from 1/2. Right? If 1/2, same as what has seen before, uniform. But now P can be more than 1/2 or less than 1/2. So it can be biased, just like tossing a biased coin. Okay. So in that case, X is a random variable that saying that number of success. Okay. Number of success is only 0 or 1. Okay. You just have one thing once and for all, whether success or failure. Okay. You will later see why we define this way. Okay. Because it's only success or fail. Why we still have 1 and 0. Okay. It will be more clear in the next set of slides. Okay. When I talk about the next distribution, this is the basic one. Okay. You can see this Bunoni is actually a guy, right? If you know mathematics, Bunoni would be a family of famous mathematicians in the 15th century, no, 16th century, no, 17th century. Okay, a bunch of guys, whole family is very smart. They invent that. Okay, and so here we have some little bit technical thing. Here is, okay, we call this success, right? So equal to 1, it will be P. When equal to 0 is 1 minus P. Okay, so this is a good one. Okay, but being a mathematician, as they are, they make it a rather complicated expression. Okay, for the probability function would be P raised to the power X, 1 minus P, 1 minus X. Okay, looks insane. Okay, at the first time. Okay, so what is it? Okay, do you know that X can be only 0 or 1? Okay, when X is 1, this is 1. 1 minus 1, 0. So this is 1. So just P. When X is 0, this is 0. This is 1. 1 minus 0, this is 1. So this is 1 minus P. Okay, so this looks crazy, but this is not fun for this one. And why we need that? Because this is what the textbook looks like, and to do the next one, then you know why it's it. Okay, so this is a rather standard way people write it. Okay, you will know it. Next slide. This is why this is so. We need that. Okay. So again, tossing a fair coin, one experiment, a binary outcome, or we just divide into our sample space into success or failure. Okay, and we can prove. Okay, actually you can imagine that the mean will be p, the variance p times minus p. Okay, we will do a proof, or just go over the proof. This is the only proof we do for this set of slides. Okay, this is only proof. I go to proof is not saying the proof is something you need for the exam or assignment, but just telling you that how you do the proof. Okay, and you have some idea of how to do those. Okay, it's not something I mean, if you get it, you get it. Don't get it, get the idea. The important is to get the idea why there's a proof behind. Okay, this is the formula there. Okay, but before I go to the proof first, I want to give you the idea why this is true. Okay, because when the mean is what? Mean is just you repeat this many times. What is the ratio of relative proportion, right? So it's just this, right? Is if you repeat many times, then you should expect P of them is success. 1 minus P of them fail, right? Because that's P is success, right? If P is half, right? You know, toss a coin, half of them will be a tail, half the head, right? The expected value will be half, right? So same idea here. This P means that if you repeat the random experiment, right? P of them is success, 1 minus P fraction of them will be fail. So expected value, if you just do it once, will be P. Okay, that means you repeat this many times, P fraction P of them will be success. Minus 0 fail. Okay, so there's nothing. I think that should not be an issue there. About the interesting part is this guy. Okay, variance is P times 1 minus P. Okay, remember this is a risk, right? Or variation. Okay, look at this equation, P times 1 minus P. Maybe I draw a picture here. P times 1 P. Okay. If you still remember your high school math, it's P times 1 minus P. This will be a inverted U shape. Okay. Maybe use other color. This is 0. This is 1. Okay. If P is 0, 0 times 1 minus 0 is 0. So this is 1 point there. If P is 1, 1 times 1 minus 1 is 0. Okay. And the question is, this is between 0 and 1. It must go up and then go down because it's continuous, right? It cannot go this way. It cannot go flat, right? You know, somewhere in the middle positive, right? And you know, actually you draw it, it's something like this. Okay. And here is 1/2. And here is 1/4. Okay. If you don't know, go back to ask any of your cousin who is doing the high school, they should know it. Okay. So why this thing is significant here? Okay. You do notice the variance with the risk, or the variation is highest when it's 1/4. So 1/2. When it's P is equal to 0 or 1, the variance is close to nothing. Why? Because say if P is very close to 1, that means that most of the time is successful. Then there's no variation because always 1, right? When P is close to 0, that means you always fail. When you always fail, there's no variation too. Okay? When it has the most variation is when it's half. It's likely to be half of them success, half of them failure, then it's very likely that the most variation. Okay? And symmetry on both sides, right? Because you call fail and success is symmetry. Okay? So that's why it's both sides. Okay, is that okay? Okay, so again, it means that if you know how the stock is going to be, then you don't have risk at all, right? That means that if you do insider trading, there's no risk, right? You know it's going to be there, right? Or if you are not very smart, okay, then you don't have variation. You always lose. You're very smart, then you always win. So there's no difference. Only when you don't know, then you just randomly betting. There's a lot of variance, right? So that's why you go to Macau casino, then it's highest variance, right? Because you don't know. If you study hard, right, then you get A for this class, then there's no variance. If you're lazy, you skip the class, you don't do assignment, you do the exam, and you always get F, right? The most variance is like you pay attention a little bit, do some assignment, but you don't take too much effort, then do a bit higher variance. Okay, unfortunately, maybe that's the case for most of us for real life, right? So look at the graph. If the equal likely, the same as uniform, right? If not, right, then you will be skewed to the one side. Okay. If 0.7 will skew to the other side. Okay. But as I promised, I will just give you one of the basic proof. Okay. This only proof I will just go over and that's it. Okay. I'm not going to do any proof. Expected x will be x times p of x. Okay. Just remember here, x have two values, 1 or 0. Okay. 1 has already p, 0 is 1 minus p. This is 0, this is p, so that's why it's p. Nothing new here. Where's the x? We just from the definition, x times expected value x, which is p, times the probability. Okay, so either it's 1 or 0, 0, 1. The mean is p. We take a square. Probability of 0 is 1 minus p. 1 is p. Okay, and you just p become p squared, right? 1 minus p squared. So there's common factor p and 1 minus p. Factor it out. So this is p left here. For this part, it's 1 minus p. P plus 1 minus p is 1. That's why I give you this equation. Again, this part is, as I said, it's not required for your assignment or your test because I make it great. The only thing is just to tell you how all the formula, like afterward, will be proved in the same way. Okay. But as I said, we are not going to do any proof. Okay. But just the idea how these things are being proved. Now we have something more interesting. Okay. So we said we have experiment, we have some sample outcome which is classified as success and failure. Success probably P, failure so minus P. Okay. The question will be, if we repeat this process n times, okay, each outcome is independent. Okay. Whether the first time success is independent or second. Okay. So what? Asking how many number of success. Okay. The example would be each day the stock market can go up and go down. Okay. The question is asking us how many days the stock price goes up. How many days stock price goes down. Okay. And why you care about that? Example would be you want to judge the sentiment of the market. Okay. If there a lot of time go up and then go down, right? Then you think the market is a bull market, right? If more go down and go up, it's the bear market, right? They calculate probability, okay? Those kind of issue, okay? But anyway, the n trial, so there will be 0 up to n, right? Because there's an addition 0 because you may not have a success, okay? If n is success, n, okay? So using comparatorics, actually we learned last class, the probability will be like this, okay? I will explain once or twice why this formula makes sense, okay? And then if you do it, you don't do it, then just take it as given. Okay, you understand later, but I try to explain why this is the probability. Will make sense. Okay, so remember here is you have n different experiment. Okay, each one is independent. Okay, so asking that if I don't care about order, right? Out of the n possible outcome, I want x of them successful. Okay, what's probability of this? And each one have probability p. Okay, so I ask the first question: what's the probability that for the first x time you success, the rest are fail? Okay, let me repeat the argument. The first x time success, the rest are fail. Okay, and they're independent. When each one is independent, right? The probability of the join will be the probability of the product, right? Because they're independent, right? Probability. What I meant is probability, because they're independent, probability of a successful in the first time and successful the second time will be probability of successful first and probability of success second. Okay, because they're independent. Okay, independent, you don't have to do conditional statement. So this is the multiplication rule. Okay, so that means that if only will be p squared, p times p, success is p. Okay, if you have 3 times, it will be p times p times p. Okay, is that okay? So if you want x success, it will be p times p times p times p times p. That's why I raised to x time. But that is this one. Okay, and then you want the rest of them are fail. Okay, again the same thing, success things to fail. So that's why 1 minus p raised by n minus x. Okay, then repeat this argument again because they're independent, right? So I want success, 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 fail, 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 fail. What's probability of that? Will be p times p times p times p times p until x times, and then n minus p, n minus p, n minus p, n minus p. Okay, so that will be the case. Okay, that will be the one realization. Just all success, then fail. Okay, but there are many different ways to achieve x success, right? Because you can have all fail first and then all success, right? The same thing, right? You just this and multiply the other way around, right? Just go for the fail thing because, and then how many different ways you can order? It's just NCX, right? This is, and so that's the idea. Okay, if you get it, you get it, don't get it, doesn't really matter. Okay, we're not examining on why this formula is correct, but that is the reason. But let me repeat again in case you want to understand, but if you don't want, it's okay. Okay, because I don't think I realized until very late. Maybe I studied the second or third course of probability. I really understand what's going on there. Okay, it's okay not to understand what's going on, but I try to convince you this is the right formula. Okay, so first is if you don't care about the order, I want success, 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 and then fail, 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 fail. Okay, what's probability? Because the first one success is p. Okay, I do second time I want success for p again. Okay, so on and so forth. I have the x of the times I want success. It's p raised to power x. And then once I do all the success, I want all the fail. Each fail is 1 minus p. Then 1 minus p, 1 minus p, minus p. And let's give you this. Okay, why multiplication work? Because they're independent. I want to do success 2 times, they multiply together. Okay, the key is independent. Okay, and then because of now I only care about number of success. It's not how it's success, right? Success all the time and fail or the rest is one way to do it, right? But also I can have fail all the time first and then success again. If in that case, I want all the fail first is this, right? 1 minus c minus c minus p minus c. And then I want success for the rest will be p, right? But this is also only one way to do it. Another way to do it. The other way will be success, fail, success, fail, success, fail. As long as you go back and forth until you have x of that and minus x of that, right? And all these things are contributing to this. This is union, right? Because they are all I said is mutually exclusive, right? Because it's like success all first and then all fail, or all fail success. They are mutually exclusive, right? And that's why you add them all up. And how many of them? The same thing. So that's why how many of them is n cx. So that's why you add them together. Okay, because all different kind of ordering is mutually exclusive. So you use the partition rule, right? It's axiom 3 of the probability. So anyway, if you don't follow, it doesn't really matter. Okay, as I said, from my personal experience, I don't really understand what's going on until I take the second class of probability. Okay, from my experience. But what I understand is I remember this formula. Okay, but for your case, it's okay. I don't think you need to remember, but just to give you an idea. Okay, but the good thing is the formula is rather simple. Okay, because this is thing you don't really care that much. Okay, maybe you care when you do about XL or R, but what is the most important is the mean and variance. Okay, because these things are usually calculated from the calculator. You don't really worry too much. The key is to see this NP and NP1 and minus P. This one is not difficult to see because the independent sum of each random variable will be just n times that. Okay, and variance the same because independent. So variance of the sum independent will be just sum of the variance. Each variable has variance p times minus p. Okay. If you don't follow the logic, it doesn't really matter. Actually, there's a proof behind, and as I said, we don't do the proof. Okay. So just to see the graph will be if p is half, it's like a bell curve. Okay. And for your view application, most of the time when this is the n is big, okay, and p, and then we will do a bell curve thing. Okay, but just to illustrate, when n is 4, p is 0.3, will be look like this. Okay, will be more skewed to the right. Okay, and let's see example. I think that will be most important. Okay, so this application, okay, is a restaurant owner. Okay, that's something very commonly we see is the owner owns the shop and he knows 30% of them are spicy food. Okay, the question is, if you have 5 customers, how was probability that like spicy food? Okay, why you care about this crazy random variable? Okay, the question is, if you're restaurant owner, you can't prepare every food for every customer, right? You have to decide how many food you can want to order. Then you calculate the probability. Is it high enough to prepare, right? If this is okay, you want to calculate 2 or less, right? And in that case, 2 of them like this. You can calculate 1 of them like this. And so then you can decide how many spicy ingredient to keep in the store, right? Because you want the ingredient to be fresh. Okay. So this probability, okay, will be because 5 customer, you choose 2 of them. Each one is randomly drawn. It's 30%. Raised to the power 2, 0.7 raised to the power 3. Okay, then you can see how much spicy ingredients you keep in the store. Okay, that is way standard in the business application. Okay, is that okay for this? There's nothing new there, except just plug in the equation. Okay, and as I said, I don't know a proof. But before we continue, I just want to emphasize that this is the most easiest thing you can imagine. Okay, because just failure or success, and then you just draw the sample, and you may ask how this coming from the data, right? Percentage, and then you can guess in general how many people are there. Then you can decide how many things you reserve, right? So same as the subway company, right? They had to decide how many trains have to reserve, right? And look at the power company, right? In Hong Kong, they reserve 120% of their power, right, as a reserve, right? And you can see China, right? And they don't reserve enough, right? Then the power outage happens. Okay, so this is the formula. Okay. Now, this Poisson, okay, is actually very close to what we have just said. Okay, it's just a special case where n go to infinity, or in the cases when n is very large. Okay, you repeat this trial many times. Okay, and then you may ask, okay, how relevant is this? Right? Just to remind you that this is again just a binomial distribution when n is very large and p doesn't go very large. Okay, n is large, p doesn't go very large. Okay, n goes very big, but p is not very large. Okay, so what is the application of this? Okay, but that first we don't prove it. Okay, turn out to be for that complicated expression will be equal to this expression, and lambda is just n times p. Okay, when n is very large but p is not very large, this is still manageable. It's still a number, and then you can have this e to the negative lambda and lambda x and x factorial. E is just a number 2.71. I see already. Okay, so what is the application of this one? Okay, why I care about this? What's the use of this one? When we would divide n into infinity very large, okay, is to measure arrival or customer. Okay, so what do you mean by n1 trial? You can imagine that at once we are talking about at 1 second or 1 minute how many customers enter the store. Okay, you can calculate by hour, by minute. Okay, but if you cut the time into very small pieces, okay, in that case you can cut x very big, p can be very small, right? Because at every single incident a guy comes in very small. Okay, so that's why you can measure the arrival rate of customer. Okay, you can model this and turn out to be the mean and variance the same. Okay, so remember this is a case for binomial, which means that when n is large, p is small, the mean and the variance are the same. Okay, but this is expected. Remember the mean and variance like this. NP and when p is very small, this is 1. Right? So they're the same. And what an application, because I think application will give you the idea, but just to before we go application, it's like when lambda is small, looks like this, but when lambda is large enough, then it looks like a bear. In fact, when lambda large, it's really like a bear. But anyway, give example, okay? Application for business, how you model how many people come in, okay? It's a Poisson distribution. It's like number of customers for a restaurant for each hour follow Poisson with mean 5, and Poisson will be fitting a purpose, right? Because you think every single second is a binomial trial, right? Or binomial trial, okay? Then in that case is fine, okay? And what exactly 2 customers arrive in next hour will be this. Just plug in the number, okay? E to the lambda is 5, 5 to the 2 factorial. Okay, so this will be the most important thing, is because when we model a lot of the arrival rate, if we use the Poisson. Okay, insurance company use Poisson, right? How likely that things happen, because we don't know n, right? Number of tries is difficult to estimate, but we can estimate this kind of thing, right? Make our life easier, right? Because when it's binomial, we need to know n and p in the calculate, right? But when we do Poisson, our life is easier. We just need to know what is the mean of the past from data. They give it lambda, and then we can measure. Okay, our life is much easier. Is that okay? So this is commonly used. Before I continue, is there any question? So this is measuring the rate of customer, rate of certain things happening, and just you can imagine this is model demand and supply, and this is same people doing about stock market, right? The stock market people come in and buy and sell. You can estimate those, okay, in terms of stock market. Last one, I don't go do any proof, okay? The last one is called the hypergeometric distribution, okay? So this is what we call the quality control, or what we call auditing purpose. So we have been talking about so many finance and marketing. So now we talk about accounting application. Okay. So what's this? This is closely related to binomial, very close to binomial. Okay. Because remember the case of binomial is every trial is independent. Okay. But now we talk about not independent. Okay. By trial independent means that, remember the question about if I earn, we have black ball and white ball, 3 black and 3 white. Okay. Then the probability drawing a black ball is 1/2. Okay. The first floor. If I put it back, it's every time is 1/2. Right. If we change the composition of black and white still, every time the same. Okay. Then it fits the idea of binomial. Okay. Just put it card, right? But now the question is not the case, right? Suppose I draw a ball from there. I don't put it back, right? The first ball I draw, the probability is say 3 black and 3 white. The first ball is 1/2, right? 3/6. But the second one is no longer the same because you only have 2 ball, 2 black ball and 3 white ball, right? Will be again draw the black ball with 2/5. Okay, smaller. Now, the question in general is like this, okay? You have n different items, okay? N of them, you can imagine A of them is good item, okay? N minus a bad item, okay? The question is, suppose you go there and pick up n items, small n items, okay? You draw a small n item. You're asking out of n item, x of them are good, n minus x is bad. Okay, let me repeat the statement. You have big n item there. Okay, A of them is good, n minus a is bad. Right? And you try to go there, try to draw small n items. Okay, you're asking x of them are good, n minus x is bad. What's probability? Okay, why you care about this? Quality control. Right? Suppose the auditor, okay, you go to the warehouse, okay, and that guy claim our machine is not very working. We have 10 products here, okay, and 4 of them maybe big guy, right? We have 10,000 products there, okay. They said 4,000 is a bad item, or 6,000 are good, okay. Then you want to tax his claim, okay. What we're going to do is just try to maybe draw 10 items, right? You want to see how many of them success, good, 100 bad, right? And then you want to, if you want to justify whether he's doing right or wrong, you want to see following what he said, right? If a lot of time it's going to be a bad item, right? More than you think, then you will try to think about whether his claim is correct or wrong, right? Let me repeat this statement is you want to see whether what he claimed is true or not, right? And then you try to look at what your data collect and you figure out that that is unlikely, right? Suppose he claim out of 10,000 good, okay? Most of them are good, only few are bad. But if you do the calculation, right? Maybe you take sample of 10, most of them are bad, right? Then you will say this guy is cheating, right? And then how you say it's very unlikely by this calculating probability, okay? And in the detail, we talk about this in the other classes, but just give you the probability, okay? With this formula, I'll quickly 1 minute, I just finished, okay? So denominator of n item, you pick n of them, so this is probably down there. And a item, you have to x of them is true. N minus a, you want to pick n minus 6 of them. Okay, bad item, this is bad, this is good. Okay, and multiply because it's the you have to do bad and good, right? It's the principle of counting. Okay, so I just want to emphasize the last thing is this equation is A over N is P, right? Probability success, right? And it's NP, and this is NP 1 minus P, and you have this factor we call the finite sample correction factor, which means that if the big N is very large, a lot of things, this is close to 1. Then binomial and not binomial, you do binomial or hypergeometric doesn't really matter. Okay, I don't want to take more of your time. We'll continue to do it next class. Okay, sorry, right? Over a little bit, but that is you can say example, those kind of things. Okay, we'll talk about this again. Okay, I'm sorry I can't finish it, but I think we can talk about this next class. Yes, enjoy. I will see you on Wednesday. I think we have a computer lab, so remember to go to computer lab. Just a reminder, homework 2 is due on this week, Sunday. Okay.